Hello, my name is Rob Garner. I'm a computer programming instructor. And last time I created a demo for how to make a generic um, menu program. So let's see how this works. We can pick options and it shows us that it's doing those options. And this generic program doesn't do a whole lot. If I put something that's not in the list, it tells me it doesn't understand that. And then I can quit and we have basically the ability to run a menu. So the next thing I want to do is use this to do something. So let's make a program to generate or we'll make a pizza order program. And we'll put a comment header on the top of this thing. And so we're going to use the same approach. And so once again, I'm going to, and the way this is going to work is this. It's going to display header, display goodbye, start a loop, and get users choice. And these are the options. We're going to, in fact, what we're going to create a loop, and maybe what we'll do is we will display pizzas first. So we're going to display the pizza orders, and then we are going to get the user's choice. And the choice options will be add a pizza, remove a pizza, edit pizza, maybe we'll save the pizza order and then open a pizza order. And then, of course, we need to be able to quit. And maybe what we also need is, well, actually, we'll just do that, just to keep it simple, or simpler. So those are our options. And so this will go into our main part of the program. If and let's define display header. And we'll run that. So we have welcome to pizza order. Thank you for using pizza order. So we have our hello and goodbye on our program. And now we can start our loop. And we don't have pizzas yet, so let's just do the menu. We're just going to use an input. This menu is getting kind of long. And I'm going to just want one character, and I'm going to uppercase it. And because this is kind of, so let's give that, and then we'll return choice. We'll see what that looks like. That's not too bad. I want a little separation there, so let me maybe do this. And so what I'm doing is I'm getting the user input. I'm ignoring everything except for the first character, and then I'm uppercasing it so that I get a consistent case, and it'll be case insensitive, but using uppercase rather than lowercase. And so here it doesn't really matter what I put. It's not responding to anything yet, but now I've got my menu. Now, let's implement the quit, and so we can actually quit this program. And notice I don't have to go in order, just because this is the order my program ultimately will run. I can build this program in any order. So the quit makes sense to implement to me right now, because then I can. So there, what I'm doing is, if the choice is Q, then we're going to break. So if I put anything else, it continues on. But if I say Q, it actually stops and thanks me for using the program. Now that we have that, we can start. Well, we need maybe the best place to go next is adding a pizza. And so we'll need a function to handle adding a pizza. And how are we going to do this? Well, we need something to keep track of our pizzas. And the way to do that is we need some kind of a data structure. Probably the logical one, since we're going to be adding and removing things to this, is a list. And so I'm going to create a variable called pizzas, and I'm going to make an empty list. So this makes an empty list, open, close. If we were going to make empty tuple, it would be like that. If we're going to make an empty dictionary, it'd be like that. We're going to make an empty list. And so this pizza, this add pizza method, we're going to need to pass the list of pizzas to this method so it knows where to add the pizza. And we're going to ask the user for the inputs. So, well, what types of choices can we make for pizza? Let's maybe say size is equal to input. Please enter pizza size. And we're just going to limit them to small, medium, and large. And again, we'll do this thing where we'll just take the first character of whatever their input is and uppercase it so that we just have one thing. And then we have size, and then we're going to maybe we need some toppings. And we could do this. But then we would get one string with the toppings. It would be nice to have those toppings in as, some kind of a collection or a sequence. Maybe another list. So maybe what we'll do is we'll do this. We'll say while true, we'll print a little header here so that and so what we'll do is we'll ask them to enter the name of a topping. And again, we're going to need some place to store this. So let's make an empty list for toppings. And we will then say, please enter a topping or enter, just stop. And so we'll enter one topping here. And then at the end, we'll say toppings dot append topping. So what this will do now is it'll ask user for the name of a topping, and it'll keep adding it. And then add it to this list of toppings. And now we've got this list of toppings and the size. And what we're going to do now is we've got this list of pizzas. We're going to say our pizza is going to equal, maybe we'll make it a tuple with the size and the toppings. And we're going to see that what this looks like eventually. And then what we're going to do is we're going to take our list of pizzas and append this pizza. So we're actually going to get kind of this nested structure. This will be small, medium, or large. This will be actually a list inside of this tuple, which will have a list of toppings, and then our pizzas will be a list with that tuple inside of it. So it's going to be kind of a nested data structure. And now the temptation might be to return pizzas. We can do that, but we actually kind of don't need to, and we'll see why here in a second. With data structures like lists, when you pass it in, it actually retains this reference. You actually can, unlike other variables, with a list, if you modify it inside of a function, it'll actually modify the original one out here. So we'll check to see if that works. And so what we're going to do is say is if choice is equal to A, then we're going to call the add pizza function, and we're going to pass in pizzas. So we're we're passing in this list of pizzas to this function. We're getting the size of our pizza plus a list of toppings from the user. We're taking that size and those toppings, making a tuple, adding it and calling it pizza, and then we're appending that pizza to this list of pizzas we passed in. So let's do this. Let's put a stop point there and run in debug mode and see how this works. So here I am. I'm going to add a pizza. So here we are at this function call. I'm going to step into adding pizzas. So if we look at pizzas right now, this pizzas was created over here and then passed into this function. We now have a reference to that, and it's an empty list. Let's get the size. I'll make it a medium pizza. And then we're getting into our loop, and we ask, and so we'll put cheese, and let's take a look. So now notice that toppings is a list with cheese in it. Pizza's still empty. We step through. And unfortunately, we're in an infinite loop here. We'll have to fix that in a second. So, and then if I put, let's see, anchovy. And now if we look at this, we're now going to append. And notice now our list has anchovy in it. We run again. And let's see, anchovy and a pineapple. That's usually a good combination. And now we can see we have a pizza with cheese, anchovy, and pineapple. And you can see it's building a list, but we don't have a way of stopping this right now. So if I hit enter, it doesn't actually stop. It just appends an empty string. But that tells us how we can stop this. We can look for empty strings. So let's stop this, and let's put in here a breakpoint, and we'll say if topping is equal to that empty string, that means that they want to stop. So we'll break here. So now we have a break, and let's run this program again in debug mode. So I'm going to add a pizza. We're now at add pizza. We step into the add pizza function. We ask for the size. I'm going to pick medium. And we go into our this internal loop. Please enter a topping. Let's see. Again, cheese. Always have to have that. And that's going to check to see if topping equals breaks. Well, if topping equals cheese, so it's not an empty string. It's not going to break. We're going to append that topping. We're going to come back around and ask for another one. We get the anchovies added to the pizza. Always good. And now we're asking for another one. And then pineapple. And again, we haven't broken. We're coming back around. We ask, and now we're done. We have everything we need for the perfect pizza. We're going to hit enter. And now notice that topping is an empty string. If topping equals empty string, break. Now notice that we break out of this while true, and we are now into this part here where we're creating a pizza. So we have toppings, which is this list. And now we're going to make our pizza, which is going to be the size and the topping. Watch what this ends up looking like. So here, let's stack these a little bit. You can see that our pizza has a size, M for medium, and a list of toppings. So we have a list inside of a tuple. And this is one of the nice things about Python is you can mix and match everything inside of your data structures. And so it makes sense for this to be a tuple because we're not going to really change this outer part, but we might modify the list. So we make this a list. And then we're going to append this pizza to our empty list. So I'm going to do that step. And when we come back out, we can see our pizza ends up, or end up getting, let's see if we can see the whole thing. Yeah, so basically what we have is we have one pizza in here, which is the tuple. The tuple has the size, which is medium, and the list of toppings. So we have a list inside of a tuple inside of another list. So I'm going to get rid of this breakpoint and move it down here so that we can see the result. And choice is currently from the previous call was A, so it's not going to quit. We're going to go back up to the top, and I'm going to just continue on. So here I'm going to add another pizza. We'll just run this one. And this one will be a large. Toppings, we'll put cheese. And we will put pepperoni for people who don't want the really good pizza. Hit enter. And notice that now we have two pizzas in here. Each pizza is a tuple, which has a size and a set of toppings. And you can see them starting to show up here. So now we've got our data structure, keeping track of our pizzas, and we can keep adding pizzas to this in this manner. So that's working. So now let's see, what else can we do? We are able to add pizzas. I suppose we should be able to remove pizzas. And so to remove a pizza, what we need to do is say if, well, first let's make the function. So we'll define a function up here, move pizza. And we're going to, we need this list. So we're going to pass in our list. Temptation might be to work with this globally, but I think it's good practice to always pass in as a parameter the things you're going to use in the function so that everything comes in through the parameters, everything goes out through a return statement. So we're going to remove pizzas. Well, we need to do the following things. Get pizza to remove from user, and then remove the pizza. And so to get the pizza to remove from the user, we need to ask user. So let's do it with an index number. We need some way to get something that points to the pizza from the user. And so we could do this. We'll get an integer from the user. But in order to do that, to get that index, we need to have indices printed, and the user needs to see the pizzas. So we could list them here. We could list the pizzas here. But, you know, it kind of makes sense to me that let's just, if we're going to list the pizzas, maybe what we want is we want it up here to display the pizzas. So let's make in order to remove the pizza, we kind of need a function to display the pizzas. So I'm going to put it up here because it's kind of, I'm kind of keeping the functions in the order that they generally execute. So I'm going to say display pizzas, and I'm going to pass in our pizzas. And for now, let's just print our pizzas and see what we have. So here we're going to display our pizzas. We're going to pass in this list of pizzas. So we're passing in this list. And we'll see what we get. When we do that. And I'm not calling this remove pizza yet. It's not done. We're okay, I think. But first, let's see. We need to have the pizzas displayed to be able to pick one. So let's run this and see what they look like. And again, remember, display pizzas is just printing pizzas. And so here we go. We have a list. So let's add a pizza and see what ends up happening when you add one. Medium, cheese, anchovy, pineapple. And you can see, well, we've got this list. It doesn't look great though, right? You know, I mean, it's okay. But when we didn't have anything, it didn't look good. And when we displayed them, that's not a very good look. So let's see if we can improve this. So I think what we should do is maybe we'll try this next. We'll iterate through them and display it. And the other thing we should do is we can say if pizzas, if the len of our pizzas is equal to 0, that means we don't have any. Then print no pizzas yet. And then else, then we'll go through and we'll loop through them and display them. So this way we can, if there's nothing there, we can display at least an elegant message. So let's try that. So no pizzas yet. So that looks much better, I think. And then we'll add a pizza, medium. Okay, it's looking a little better. So this is looking a little better, but I think we can make this even better. Maybe what we could do is we can do this as a format string, and what we'll do is we'll display pizza, and if I go pizza of 0, that will be this element, which is the which is the size. And then I have this list, and we'll say pizza of 1, and that's going to give me the second element of this tuple, which is this list. And so let's run that and see what we've got. Let's quit this here and then run it again. No pizzas yet. Add a pizza, medium, mushroom. Medium pizza with mushroom. Okay, that's looking pretty good. Square braces aren't great, but it'll do. And then we can add one, a large cheese pizza. We'll keep it simple. And so, yeah, that works okay. But we can improve that, and the way we can do that is, this is a list with strings in it. So what we can do is we can say, Let's join that on a comma. So comma dot join, and we'll see that this will work a little bit better. And so we can do this, and we can add a medium cheese and sausage and green pepper. Medium pizza with cheese, sausage, green pepper. Okay, it looks pretty good. And probably put a space in here. And so, okay, there, that looks pretty good. Maybe we'll even put a period at the end of it. Okay, I'm satisfied with that display of the pizzas. But the other thing we need is it would be nice to have an index number. And so that we could specify which choice. So in here, it would be nice to have, some kind of number. And if we want to do that, then we could put a counter and keep track of. But there's another way we can do this. Well, yeah, probably. Yeah, maybe I'll do it this way. Index is equal to 1. We're going to start off with 1. And we're going to display this index. And then we will say index plus equals 1. And so what will happen is this index will keep incrementing, and we'll have this index number next to it. So let's see what that looks like. Now we have an index number next to it. We're going to add another one. Large cheese. And we can see now we have these indexes now. So this will be useful when we want to delete, because then we can use this index number to indicate which pizza we want to remove. Okay, now we can get to the delete. And so here we go back to our remove pizza. So we're going to ask for the index to remove, and then to remove that pizza. Basically what we want to do is we have our pizzas, and we want to remove that. So we can do this with the delete command, and we will delete. We'll say pizzas, and we'll delete the one, use that index to remove it. Now, this has actually got an error in it, but we'll see if we can figure out this error in a second. So I'm going to go ahead and run this as, actually this won't work yet. We need to actually bring it in here. So I'm going to use an elif. If choice equals R, then we're going to remove pizza, and we're going to pass in our pizzas. And this can actually be an elif as well, because if it's only, these are mutually exclusive, so we're going to do all these with an elif. So we're going to run that, and so this will go to our remove pizzas, and so I'm going to hit remove or add pizza, And so let's put some in here. And then add another pizza, medium, anchovy, cheese, pineapple. Now we've got our 2 pizzas. And now I'm going to say remove pizza. Well, you know, obviously this is a way better pizza than that one. So we're going to remove pizza 1. Wait a moment. I said remove 1, but it removed the second one. Why is that? Well, lists are 0 indexed in Python. So when I put a 1 in here and I got this integer and then I removed index 1, actually large pizza with cheese was at index 0. The medium pizza with anchovy, cheese, and pineapple, that was at index 1 because lists are 0 based. So we have to, when we ask the user, we're going to show the user a 1, you know, starting with 1, because if you put 0, it's going to confuse most users. But what we need to do is we need to adjust this. So we actually need to put a -1 here in order to get the index. So I'm going to quit and then rerun this and see if this works again. So we're going to add a couple pizzas, large cheese, add large cheese, pineapple, and anchovy. And then we're going to remove a pizza. I'm going to remove 1. And yeah, it removed the correct one. Of course, it renumbers it because of the way we have this working. But that should be okay. Let's see if I can remove the next one. And now we have no pizzas. What happens if I remove 3? I get an error. So I actually also need to do some validation in here. So before I delete, I'm going to have to check to see if index to remove is greater than 0. It's going to be 0 because even though 0 is a valid number, remember, we're going to eventually remove -1. And index to remove is less than the len of pizzas. And it's really, we're going to do less than or equal to, because, you know, if there's 5 pizzas in here, then 5 is a valid number, even though the index of the last one will be 4. We're doing this, we're removing this value already. You could also put your -1 here, and if you did that, it would shift everything. So this would be less than or equal to 0, and this would be less than length. So you can do it either way. You just need to account for the fact the user is going to be putting something based on 1, but Python depends on it to be 0 based. So either way will work, and maybe what we'll do is else if it isn't, we'll say print that is not, that pizza does not exist. And so we see here, even though I tried to remove pizza 3, there's no pizza there, so it tells me it doesn't exist, and it goes back and we're still operating. So this validation helped us make sure that our pizzas were removed okay. Okay, so now let's, what else do we have? We display header, we display pizzas, we got the user choice. Let's, you know what? I don't think I'm going to do edit pizza. I think, you know, it's so simple. We probably would just delete a pizza if we needed to. So let's take that choice out of here. We just delete and add it. So we'll just do that. But now we want to save the pizza order. So we're going to pass the list of pizzas to the save method. And we're going to open a file. And we're going to need a file. So we need a file name from the user. So we'll say file name is equal to input. Please enter file name. And then we'll say f equals open file name. And we'll open it for write. And then we will say f dot. And then we need to go through our pizzas, loop through them, and write it to the file. So for pizza in pizzas, let's just write that pizza. And okay, I'll just do it this way. I'll just create a string out of that pizza and then add a carriage return to the end of it and just see what we get. And then f.close. So here we're going to say elif choice is equal to save save pizza order, and let's see what happens. And then we'll hit save. And if we go up here, there's there's the file it made, and that's what it looks like. Well, that's not too bad, but it's really not a good data format, I think. We could probably improve on that. I think it would be easier to read if we didn't have these parentheses in here. And maybe these square braces might be useful. So let's improve how we're saving this. So in here in our save pizza order, we can maybe we can be a little bit more explicit in what's going on here. So let's f.write the and this is where the format string can actually come in handy. We'll put the pizza order. We'll put a comma, and then actually what we could do is we could plan on we save the pizza and then we save all of its toppings afterwards. And so in this case, maybe it goes something like this. We would say again, we'll take a comma dot join, and we will join pizza index 1, which is that list of toppings, and we will put at the end of all this a \n, so that will put our carriage return. Let's try this again and see if it What happened? Okay. Let's see. What did it not like? Oh, because I used a single quote here. We'll surround it with double quotes so that it doesn't get confused by these single quotes. Okay, let's try that again. There we go. Adding a pizza. We'll save our pizza order. That's 2 pizza order.txt. There it is. Let's see what we got. Okay, so now this actually looks pretty decent. Separated by comma. I think one little thing I might do is put a space at the end of the comma just to kind of move it apart a little bit. But now we have something that's in a reasonable data format separated by comma. And, you know, actually now I think about it, maybe what we want is, maybe let's use a tab, \T. I find that tab separated works better. It doesn't like something. Do that. Okay. It's not going to let me join in here like this. So what I might do is say pizza list or toppings list is equal to, and I'll just pull this out. So we'll do a \T for the tab between, and then we'll put that toppings list in there, which will be split out that way. So I think this will work okay. And let's see. Yeah, so now we've got tabs between here. I think that'll actually work better overall when we go to read it. Okay, so now we've got a pretty decent data format. Now we need to do the reverse, which is open pizza order. We actually need the reference to the pizzas in here. And what we're going to do is we're going to clear that list. And so that we have an empty list now. And then what we're going to do is get a file name and open that file, just like we did here. We're going to open it up for read. And then once we have it open for read, we're going to do a while true. And we're going to say line is equal to f dot read line. So that's going to read one line in. And if that line is equal to an empty string, we're going to break. And we can actually do this by just saying if not line break. If we get something, for now let's just print that line and see what we get. So we're going to save that. We're going to put it into our menu choices. And let's see what we get. So I'm going to open my pizza order. Test3 pizza order.txt. And okay, so we're able to read this. These are actually tabs in here, \t's. And so we've got these. So what we're going to need to do is make a pizza by taking the first element that we read and then make that the size, and then make these the list items. So we can go back here and let's do the next step. So we've got the line. Let's just say elements is equal to line.split, and we'll split on the \t since we used a tab character. And we'll do that after this check to see if it's a break. And let's print elements, see what we've got. So again, let's quit this. And run it. We'll open our pizza order. And now we can see that this split has given us a list, and now we can get this first element and then get these second elements. So let's do this. We've got the elements. We're going to say that the size is equal to elements at index 0, and the toppings is equal to elements, and we're going to use a slice, and so what we're going to say is from 1 to the end are the toppings, and then we'll say our pizza therefore is equal to a tuple with size comma toppings. So we're rebuilding our pizza from the file. And look at that. Now this is starting to look like this. We have this \n, which we're getting at the end. We kind of don't want that \n. And it's kind of happening here when we read this line. So let's see what the line looks like and see if we can figure that out. And so, yeah, you can't quite see it, but there's there's a carriage return at the end of this. So what if we did um, we'll go from the beginning to, and we'll omit that last character. And look, now this is all one. It doesn't have that extra carriage return. So I think that clears out that extra carriage return. And so we could actually just take this and apply it to this read line. And I think that will actually get rid of that extra carriage return. We can open up our pizzas. And now we can see, yeah, look, we got rid of that carriage return at the end. This is a nice looking list. This looks correct. So what we want to do now is we just need to say pizzas.append that pizza. We're going to go through and append all those pizzas. Again, with a list, you don't need to return it, because if you're modifying the list, it should be okay, especially since we did a clear operation here. This will work. If we didn't do a clear operation, if we said pizzas is equal to this, it actually would create a problem. It would because now pizzas in here is pointing to a new list. We come back, the one that we passed in would be pointing to the old one. So we can't do this. If we want to keep that reference. So we need to do a clear operation on the original list so that we don't lose the reference to the original list. And so let's see if this works. So we'll open up our pizzas. And look at that. We have our pizzas from our order. We can then add a pizza to this. Let's add a small prosciutto and cheese. I misspelled stuff. It's okay. And then we will save our pizza order. And we can see that there we have all of those added. And then we can open our test for pizza order.txt. Remove a pizza. Let's remove pizza 1. Save that one. I could use the same file if I want to overwrite them, but and now we can see that we're able to manage our pizzas with our console application, menu-driven application. So that's how you can create a menu-driven application using just a standard menu structure. And I also recommend doing this. Put in a final else, print I did not understand that. And that handles the cases where someone just put some gibberish in here. Allows you to loop back through and make another choice. Thank you very much.